Hello, everyone. Hi from the Deep Learning IndabaX Roadshow 2021. It is a very, very big pleasure for me to basically announce our event today, which is hosted by Spatial Edge, and the guys from Spatial Edge will introduce themselves just now to you. This will be about notebooks. You will learn how to basically not code notebooks. I know that, or at least when I speak for myself, notebooks can be very, very messy. And if people have to read them, for example, your supervisor has to read your code, it's sometimes like absolutely impossible to reproduce what you actually did there. So you will learn today how to do this the right way. Before we start, I just want to do the normal, introduction to what actually the deep learning IndabaX is. Most of you will know this by now. So we are basically a local version of something bigger, a big movement called the Deep Learning Indaba. If you don't know about it, please check it out on their website. It's like a fantastic group of people who want to promote machine learning research in Africa, over the African continent. And our roadshow this year is part of a bigger, host of events that is organized all over Africa. So an IndabaX is basically a local deep learning Indaba conference, and it can be like a day or just two people meeting as an IndabaX. But we decided to do a series of events this year to really leverage the constraints that we have this year for because of COVID. And so some of you might have been at the 2019 event. Which was really a conference. We really, really try in 2022 to have a conference where we can see all of you together, because this is always a much better idea in some sense. But so a couple of the organizers of last year came together and just said, okay, let's just do this series of events so that we don't lose the thread. And there are a lot of students who basically get a whole degree during the pandemic, and they don't have this opportunity to network with South African resources. So this roadshow is literally seminars made in South Africa. So if the hosts start having load shedding, you know what this means. We know we can accommodate each other, and maybe there's a bit more, courage to speak to each other in a different way, because we're all coming basically from the same, place overall. So we still have a couple of really nice events. The roadshow lasts until end of November. We will have a big award ceremony at the end on the 26th. I think we put it up on the webpage now. It wasn't there so far, and there we will also give the awards. We had this community forum. Most of you might be part of it. It was a bit of an experiment where we thought let's see what happens. Oh wait. Oh yeah. So we thought what happens if we just have a forum? So basically, this is the forum where we organize the IndabaX events. If we open it to everyone, and we thought maybe people start talking, and this has happened a little bit here and there. It is also an interesting insight that if you just throw in hundreds of people that don't know each other to a forum, it's not necessarily that they start big discussions, and that's also absolutely fine. But you can use this forum as a place where there are hundreds of people who do machine learning in Southern Africa or somehow connected to South Africa. And if you have a question, or if you need to find a supervisor, this is really a good place to ask. So use this as well for your own purposes. I'm almost done. So lastly, we have not only the events, but we actually have a host of competitions. You can win up to 60,000 Rand. And I want to announce two things that are really, really cool. The one thing is that we might have another category coming up, a prize of, please don't quote me on this, but also of the order of 20,000 Rand in a hackathon, a small hackathon in November that will be organized. So there will be more coming up. And the second thing, and this is brand new, I only got the email now, we will be able, if everything goes well, we will be able to offer little data grants. So we'll be able to send 10 or 20 gigs your way, because we know that also these events consume a lot of your data, and here we still have to pay obviously by the gig. By the way, Quadcast has an option to see the whole event in lower resolution, so not to be such a drain. Okay, then thanks a lot to our sponsors. I also added, so the data grants will be sponsored by NETEX. NETEX is a new center for theoretical and computational sciences. That's very exciting, institution that will be added in South Africa to the host of opportunities that we already have. And then without further ado, let me stop here. And how do I stop my screen sharing? There we go, and hand over to Spatial Edge. Thank you very much.
Awesome, thank you so much. Yes, so my name is Pierre Leroux, and I've got Dr. Jacques Dutoy here next to me. So yes, we'll be taking you guys through tutorial workflows and how to do reproducibility in terms of those notebook kind of workflows. I just quickly want to introduce who we are. We might not be well known to many of you guys, and then I'll hand it over to Jacques. So I actually see my slides being cut off, but that's perfectly fine. So yeah, at Spatial Edge, we're a big data and AI solutions company. We help big organizations with taking their machine learning models into production. So we do see a lot of different data science teams. We see a lot of different data science workflows. Jacques himself is on a lot of these different projects, helping out and giving guidance and helping the data scientists essentially to productionize the code. And that's probably a word that I don't know if some of you guys are used to that. What it essentially means is having the ability to put these machine learning models in a place where the business can rely on it, where they can continually get value from it. For example, if you build a machine learning model and this model starts making the business, say, millions of rands, 10 millions of rands a month, you want to make 100% sure that this model is in an environment where if anything happens, you can easily recover from any issues or any changes that might happen to it. So yeah, so without further ado, I'll hand over to Jacques.
Okay, great. I'm going to share my whole screen quickly. Shout out if someone can't hear. You should see the zoomy wheel there. Okay, great. Go wait for it to catch up. There we go. Okay, hi everybody. Actually, I wanted to wear my 2017 Indaba t-shirt, and I forgot. I was at the conference in 2017, and now I have this terrible mustard thing on instead. My apologies. Okay, so as Peter said, we do quite a lot of productionizing the machine learning models. So we have a lot of ML engineers, people with a lot of software engineering and data science backgrounds, taking prototypes, which are usually developed in these kind of notebook environments. If you go and work at a corporate, generally these days, a lot of these notebook tools are wrapped up in cloud platforms. So, you might, for example, be on, here's an example. So I'm going to do this a little bit loose and fast. So, feel free to ask questions, and I am going to jump around a little bit, but, you can go here, for example, onto Google Platform, and down here we have AI Platform Notebooks. Where are these guys? Where should I go here?
I would just search in the search bar.
You just search in the search bar. Okay, there we go. Usually I also don't scroll, so there you go. Pay the price. So you go to the AI Platform section, for example, and then over here, of course, you've got your notebooks there. And I mean, they're not, Google Cloud Platform are not the only ones. This is pretty much what everybody's doing. So in general, a lot of data science is being done in this environment. And if a data science prototype is being completed, then ordinarily someone is going to want to put that thing into a robust environment where they can create continued value from it, right? So the thing's automated, it's got some checks in place, it's continually running, and things aren't going wrong. So here you can see I can create one with a GPU attached or not. So I'm just going to quickly click on that, and I can create it, and it'll spin it up for me, and it'll open a Jupyter notebook for me inside the browser. So because all this work is being done in these places, really it makes good sense to meet the data scientists where they are and try to figure out how to get their code from that environment into an environment where we can run it quite regularly. So that's what a lot of the ML engineers do. They take prototypes over and they make sure that these things can continue running and do so reliably. So they check a whole bunch of stuff like, feature leakage and whether or not the distributions are drifting over time. So there's quite a lot of work that still happens after the prototypes are complete. And some of that is actually doing some of the software engineering. Okay, cool. So I'm going to quickly hop over to a bunch of slides, and then after that, we'll jump into some notebooks directly. And one of them is in a bit of a state, which is usually how you find it. And then we're going to try together to hack through that thing. Full disclosure, I saw it a few minutes ago, so it is going to be interesting. So let's see what we can do together. Cool. All right, so I'm going to try to maximize the screen. Hopefully this doesn't kill anything, but we should be able to see it on this side. Okay. Cool. So we're going to focus on the Jupyter notebooks for the reasons that I said now. So let's have a little look around here and see what we're going to talk about. So firstly, we're going to talk about the reason for being, where these things come from. We're going to quickly chat about sort of modern big data analytics, how this stuff is being done. I've already showed you Google Cloud Platform. So that's an example of pay-as-you-go compute stuff. Pay-as-you-go in the sense that, you know, you sign up, you only really pay for what you use. So that's pretty much how a lot of this work is being done at the moment. And notebooks obviously fit in nicely there. We'll talk a little bit about Jupyter and Python specifically. Then we'll talk about reproducibility. You know, what do we mean by that? And then we'll have a look at the workflows, a couple of workflow hints that you can use. So there's a myriad of tools in this area. So I can hit you with a bunch of tools, and then you're going to have to install stuff. So what we are trying to do here, maybe in this session, is just look at it from a first principles point of view, right? What's important? Why is it important? And how can you apply that to your day-to-day work without necessarily having to go and log on to some website and create accounts and do all sorts of complicated stuff. So
maybe just actually quickly pause on that one. So when you say first principles, you basically mean, you know, what are the key core things that you can do where you don't actually need the tooling. The tooling just makes your life potentially a lot easier. It takes a lot of things away. But if you know the first principles, you can apply that, then you can at least assess if the tooling is for you and if the tooling is going to help you, or like you said, you can just get started on it.
Yeah. Okay, great. So that's what we're going to look at. So the goals here are just understanding some of the requirements really for making reproducible data workloads, and then a sort of an understanding of the benefits and the pitfalls of these notebook workflows, what to do and when to do it. We'll quickly touch on right at the end. But this really is our set of principles pretty much up front. So I did this in a Jupyter notebook, so that's why the indentation is a little nasty. But the 4 bullets that you see there, the first one is data science do. Let's do more data science. So the trouble that data scientists in industry have is that they spend so much time trying to read and write data and integrate with systems. And actually what they want to do is, you know, solve the business problem using data science tools. So, you know, we kind of want to get data scientists back in that space doing data science without having to worry about any of the additional stuff. The second bullet there is data science is an element, is an object of science. You could say it's a subset, but anyway, the point is it's science. So there's an empirical process that you're typically following there. And that kind of gets lost a little bit when, you know, people are in a hurry to get results out and they're not necessarily working in a manner that makes it easy for someone else to confirm the results that they got. So that's what that reproducibility and repeatability thing is there. So that's something that we try to, we do stick to that always when we're basically taking a prototype from a data scientist into a production environment. If you're basically getting results, different results in production from what someone was building in their prototype, then there's a very complicated conversation that has to happen. Why is it happening? Is the performance now, the performance may be worse, you know, you might need to understand why that is. So you really want,
maybe something broke.
Yeah, maybe something broke, yeah.
And if you can't reproduce exactly what happened, then now it's very, very difficult to fix.
Yeah.
To debug.
Cool, so that's the second one there. So we do want to approach this with sort of a scientific mindset. And then the third one is being systematic. So what you really want to do here is consider the way the data flows through your prototype or whatever you are building in your notebook, and try to segment that up. And don't be afraid to create new notebooks, right? That's actually a very nice and easy way for you to work. Ultimately, when you get to these larger systems, and if any of you guys have heard the words like Airflow or Kubeflow or any of those larger tools, then this is actually how you work. You basically break your training out, your stage out, you break your scoring stage out, you break your data prep stages out, and they all run in sequence before, you know, you get to the results at the end of that pipeline.
And for those, I guess, who don't know, DAG stands for Directed Acyclic Graphs. And you can visualize it as a pipeline of things, events happening, and cool.
Exactamundo. Okay, cool. And then the last one there is just that we want to get closer to production. So the point here is just to say that the difference between production and your exploratory data analysis is as small as possible. So there will be differences. You know, people are doing prototypes in different environments. You might be building, you might get a data sample, you might be sitting on your laptop, you might actually be working on your laptop directly, That's probably a bit quicker than having to interact with the cloud all the time, and then you might want to move that model out to somewhere else. In that case, you want that environment to be as similar as possible. So we try to make sure that the workloads are more or less portable, right? I can work on my laptop, I can work in the cloud, I can work all over the place, I can be in production, and it's not too different from my exploratory data analysis work that I do. So these are sort of the principles. So we'll get back to them right at the end again. I'm going to wax lyrical for a bit about some of the other little bits and bobs on the way there quickly, and then we'll get to the end of the slide deck and then jump into the nuts and bolts code. Okay, cool. So the context here is that really notebooks have taken off. There was a couple of years ago, and Pierre will have a laugh at this, where I think in 2017 or so, we considered using notebooks in production. He said it, and we laughed at him. And now it's much more commonplace. So, I mean, they're everywhere. It's being used in scientific work as well, obviously. And it's really just a convenient way to document and share your analyses. So the guys, you guys in academia who are using them, I mean, you can write math. You can use math mode in there. You can do a lot of really great stuff. You can do slideshows. Notebooks are really powerful. Cool.
I've even seen people build small apps or mini
Yeah.
apps inside notebooks themselves.
Yes, you get callback functions, you can have buttons. So, they're quite powerful. It's worth putting in the effort and getting them to work nicely. So basically, they're widely used and they're here to stay. But the trouble is collaboration is quite challenging. And yes, you can go out and get some paid for tool, and there can be all this nice integration and stuff like that. But the majority of us are, working in notebooks either in the cloud, like Google Colab, or on our laptops. So you don't always have these tools at your disposal. So what we're going to talk about today from the first principles point of view is what are some of those simple things that you can do just to make your work a little bit more shareable and collaborative, and then, without having to leverage these larger tools.
It's probably worth mentioning also that even though notebooks have a lot of these benefits, there's a few things that they allow you to do, such as you can execute different cells out of order. You can they allow for caching and all these kinds of things, which could make it difficult for, I guess, new people, beginners to programming to get a hold of it, understanding. And the second thing, that also then eventually makes it difficult to, write reproducible code, which we'll get into eventually.
Okay, cool. So incidentally, these slides are code, just for fun. There's all the things we're going to go over. We're going to talk about the reason for being. This is the intro. So let's jump into the reason for being quickly. Okay, so let's stay with the scientific theme a little bit here. So I'm going to do the whole standing on the shoulder of giants. So we're going to go through a little bit of history. How did we get here? I don't know if there's people in the audience old enough to remember any of these tools, but here is Mathematica. It came out in 1988. Fantastic tool. And they defined this idea of a kernel and a front-end GUI. So in the background, there's this thing executing your code, and on the front, you having your visualizations. So the kernel interprets these expressions, and then you get this nice front end. There you have your results can be displayed. You could do typeset mathematics, and of course, your graphics could also be displayed. So this was back in 1988, and it's been going pretty strong since then. So that was the first arrival in the scene of these sort of notebook approaches. You've got syntax highlighting in that one. That's great. And then in 1992, the Maple worksheet came out, and there it was also for university that developed this actually. And there you could do text and graphics. Everything was combined into one single unit, input and typeset output still. And you can even do these great animations. So you can see everything's rather focused on the academia and mathematics as an application in the beginning. But you could do a lot of this really, really cool stuff. And this was all inline, right? I mean, it was great. The other thing as well is, there was MATLAB and these other tools, and they would usually have a coding window, and you didn't get the same flow. You didn't get this flow from cell to cell to cell. But these notebook tools generally work like that. And then along came Ipython, and that's kind of the precursor to the notebooks that I just showed you now, for example, on Google's AI platform, and the Jupyter Lab notebooks that people are pretty much using. Yeah, most people are using those notebooks. So this came from another university, UC Berkeley, and in 2001, it was open source. It uses SciPy and Matplotlib to do some of the graphing. and it allowed you to use that REPL environment, the interactive environment, for you to actually test your Python code while you were developing it as well. And you got some parallelism out of the box, which is really, really nice. So you had these non-blocking interactions. So you could actually send instructions back into Ipython and carry on working. So it was a great advance back then in 2001. And it was also running on a browser, obviously. And that was the precursor. The same authors, or at least a single author, but more authors who were involved in Ipython actually developed Jupyter. So Jupyter was the extension on Ipython, and you can see there what the purpose is. This is taken from the Wikipedia page to support interactive data science and scientific computing across all programming languages. So you can use R in a Jupyter notebook, for example. We use primarily Python. Python is just, it's pretty much everywhere if you're doing data science and data analysis these days. So JupyterLab was Ipython notebooks, and now you could have lots of these kernel things, these interpreters in the background that were running and interpreting your instructions, and that's how they get all these languages into Jupyter. It would probably be silly of me not to mention R in a bit more detail. There are a lot of people who are using R, but maybe in the deep learning space, not so much, because the tooling in Python is just so fantastic. But nevertheless, R has its own notebook that came out in 2016 called R Markdown. It's nicely statically formatted. You could share this thing quite nicely if you're doing a lot of Markdown stuff for notebooks. Generally, you'll find the R forums are quite active. But then you could also do some interactive development, and there were lots of languages that you could include. So you had Bash and Python and SQL and so on. So they kind of followed in the footsteps of JupyterLab, but not as ubiquitously used. So where are we now? So now we have Jupyter Notebooks. We had Jupyter Notebooks for most of the time, and then Jupyter Hub came along, which was a way to manage access control and have lots of people working on single Jupyter servers. And then Jupyter Lab is the latest incarnation of this whole business. And Jupyter Lab is pretty fantastic. You get lots of extensions. You can get linting, which is basically checking if the code, statically checking the code to make sure that it's correct. You get syntax highlighting. You get a whole bunch of cool extensions in Jupyter Lab. And also nowadays we have a lot of hosted notebooks. So I'm sure many of you are using Google's Colab because you get GPUs attached for 12 hours, I think it is. So, you can go into Colab, you can spin it up. Yeah, that's for free. So here, for example, is one. I'll just open the Welcome to Colab one. I think, let me just see if it switches. Yes, it does. Great. And of course, you guys have probably seen this. And over here is the connect, and here it'll allocate my environment, and I can change the way I would actually connect to this notebook. So this is pretty fantastic. I actually find that when I'm working with people, this is a nice place to work because you can just share it with them as long as they have a Google account. So Colab is fantastic. But there are other examples of that as well. Amazon's got SageMaker, Databricks, who raised over $1 billion the other day, have their own notebook stack, which is pretty cool. And then, of course, Kaggle, you can go, if you're doing Kaggle competitions and things like that, then you can also spin notebooks up there. Cool. Okay. Dave says they made us do differential equations in Pascal. Ooh, Dave must know what Mathematica is. Okay, cool. So let's jump on quickly then and have a look at what modern big data analytics looks like. There's just a couple of slides here. It's not really that the title looks fancy, but it's really simple. So everybody's kind of doing laptop data science, right? That's in the beginning. So everyone's on their local host. They're moving on quite happily. But there you're going to run into memory constraints and compute constraints and storage constraints. So it's great to work if you can get a nice snapshot initially, and then that will be extended.
So maybe just stand for quickly. So this basically means you as data scientist, you're pulling down a snapshot of the data onto your laptop. You're spinning up a local version of Jupyter Labs, and you're playing around, you're experimenting there, you're running everything, you're doing everything you need to do.
Yeah, and then you actually fall into that classic sort of developer trick, right? Where it's like, but it works on my laptop, right? So yes, I did the analysis here, and it works. Here's the file, here's the notebook, and people share it that way. But you're limited there. But the nice thing about Jupyter and the notebooks that we currently have is that they actually follow a kind of a hosted architecture anyway. So this is actually taken, I think, from Jupyter's slide. I can't remember. It's been a little while now. But this is the kind of the diagram of how it works. Your user is sitting in front of the browser, and there you have a notebook server in the background that's interpreting at the bottom here your notebook file, which is your IPython file, which is a nasty JSON file with lots of curly braces and all sorts of madness inside it. And then underneath this whole kernel, underneath the server, there's a whole bunch of these kernels. So you can install different Python kernels or R kernels or whatever interpreter you want to run underneath your Jupyter Lab. But this decoupledness means that you can anyway just move to bigger remote work environments. So what's quite common with on-premises clusters, for example, is you've got this massive compute underneath you that looks like this diagram definitely looks like it comes from the Mathematica Maple days. But here you have a sort of a huge cluster, lots of nodes, and you're actually connecting to this little edge node. So you're logging in over there, and it's routing your traffic through to the cluster. But to you, it looks like you're just working directly on this massive machine with terabytes of RAM and all sorts of goodness underneath you. So the notebooks already allow you to do that out of the box.
Basically, your notebook is your interface for working on it, and then you can now pull in all this data, use all that RAM to do whatever you need to do.
Yeah.
Nice.
Cool. So let's move on to Jupyter and Python then specifically. So cool, we got this great tool. We got these notebooks that allows us to work in the cloud. People like Kaggle and Google are providing us with free compute for 12 hours, as long as we keep going at it. And then let's have a look at a little bit more then at the notebooks and the language themselves. So really this Axeman on the right there is just to say, know your tools. So you need to know your locality and your access as well. Particularly if you're working in these clustered environments, things can get a little bit confusing. So you need to be quite clear on where your runtime is, what the kernel is that you do have. If you're working locally on your laptop with Jupyter Lab, you might do a little pip install inside a cell, and then you think, hey, great, it's going to be installing inside my kernel. No, it's not. It's annoying, but unfortunately, that's the way it works. If you're in Colab and you do a pip install, life is good, because it's just one environment, everything is pretty clear. But maybe we'll get into that when we're hacking at some code just now. So know where your runtime is, know what's going on underneath your notebook, know where your data is. This is really important as well, because maybe you're pulling a massive data source from the cloud, and it's gigabytes and gigabytes worth of data. So you really need to pay attention. These notebooks with their abstraction make it very easy for you to burn through your internet cap. Okay, so also just be aware of how access tokens work. So if you are collaborating with people, and that's what we're kind of trying to drive in this whole session, you might accidentally commit some keys into your Git repo, or share a Google Drive that's got some access tokens for your collab where you're accessing some other private data set. So just be aware of what you're doing when you're sharing stuff. Okay, so know your language and your environment. So we're going to stay on this tooling thing. So Python is basically dynamically typed. You can see an example here of the code inside that little cell block there. So here I said value is equal to 2, and if I print value, it's going to be happy days. I'm going to see the number 2, and then I just reassign value to something else, and then it'll print that string. So I can switch these things around. It dynamically determines the type while it's in the runtime, while we're busy running each line of code. And Python works quite nicely like that, but it also does mean that when you're working in a large notebook that's full of lots of changes, that you can easily override a variable and change its state without really being aware of it. Of course, if we just contrast that to C, which is properly typed, I'll say properly, but typed, then you're defining your variable types, and the compiler is generally helping you a little bit there. It's a little bit easier. You're getting a bit of a warning. Oh, look, you're trying to use this variable in a way that the type doesn't support, or so you'll get some feedback from the compiler. And that's an easier way to work, but that's not how we work in notebooks, and that's not how it works with some of these interpreted languages like Python.
So what you were saying with Python is you can have a cell ran with a specific value, and you're like expecting value to be 2, but then you run a different cell, which change value to string, and now you're running something after that, and you're like, I expected this thing to be 2, but it kind of got overwritten. Look,
so generally it'll freak out if you try to do arithmetic on a string, so that's fine, but in other cases, you can do some strange things, particularly if you have some features that are in rows or lists in data frames. You might easily override some of those types without really being aware that you're doing it.
Okay, cool. And then things don't necessarily, it might actually work, and you might get results, but then they're not correct because it didn't take into account what you want.
Exactly. Okay, so to carry on in this vein, what you'll see there, an anti-pattern little thing at the bottom right there is this, we have lingering experimental code. That's pretty common in a notebook. You're busy developing some goodies, and it turns out that you left a cell block there that's kind of irrelevant now. But if I were to run your notebook from top to bottom, it's going to execute, and that could have some serious consequences. So interestingly, there's a Google paper actually where they talk about a financial firm that had a if statement that was experimental and never executed, and somehow years later, when they fixed some bugs in their trading system, this thing got activated, and this particular company lost on the order of millions of dollars, I think. So these things are, experimental code is bad. You don't want experimental code just lingering. And I mean, if you guys are in academia using this for your research, the idea is you kind of want to keep your notebook curated, right? If you're done with something, clean it up. Create new notebooks, commit those notebooks, use the tools at your disposal just to make it a little bit safer for yourself, so that you don't have this lingering code hanging out.
I think the key there is cleaning up.
Yeah, continually. Okay, so let's quickly look at some of these variable scopes things. So here's a pretty good example of how this can get you in a notebook. So you see that first little for loop there. If I run over that for loop, it's just a list of tuples of tuples. I'm going to get A and 1 printing out the whole time. The last iteration, E, will contain the tuple C, 3, and then I can do a def show print E, and I can run show, and E is available to def show. It's amazing. That's how that works inside the notebook. So it is super error prone. You have to be quite careful with what you're doing. So I've got a little bit of a shadow variable thing happening over there, and you can see how dangerous this is. Cool. So if you are knowing your tools, then it's good to know some of your shortcuts and leverage the tooling that you have in a bit more of a power user sort of a way. So you can jump around a notebook, and maybe here we should try to make this a little bit more fun. I'm going to go here and quickly pick a kernel. Interestingly enough, these are all my kernels you see here. So I'll choose the Scratch kernel, which is just where I dump a whole bunch of packages. And it's my default one that I typically choose.
So just a quick moment. So this is the Jupyter Lab, I think you're running on your local machine.
That's right, yes. So I'm running this on my local host. I have the Colab one open here too, just for interest sake. And I think now I actually do have.
So there's a lot of tutorials. If anyone's obviously interested in asking or don't know how to do this, I think we can probably pop a link somewhere at some point to, if you guys want to open it up. Otherwise, yeah, you can just follow along for now.
Yeah, so there's the notebook in our platform that's busy spinning up, and this is all brand new and fresh, and it's running in the cloud. So that's quite nice. But let me go back to my local one.
Sure. Someone just quickly asked, what is a kernel?
Oh, great. So the kernel is that little goodie underneath. Let me zoom out these slides. Yes, I get some utility for this. The kernel effectively is the interpreter environment, the execution environment underneath the notebook. So in my case, it's a Python kernel. We'll actually do this now when we get hands-on. And I put my dependencies inside that kernel. It's just the interpreter for my Python code. And I can package them independently inside these kernels. I can also have an R kernel. Basically, think Linux kernel. It's just the brain underneath the execution of my code. Okay, cool. So know your shortcuts. You can have a quick look over here. So we have a few here: insert cells, cut cells, copy cells, paste cells, delete cells. And this is why having the same environment in multiple places is so fantastic. You can invest in a couple of these shortcut keys, make your workflow nice and efficient, enjoy yourself in the notebook, and you can apply that in Colab or in Google Cloud Platform. Sadly, Colab doesn't always implement some of these shortcuts, which is annoying. Sorry. Yes, the delete cell one is not there. So here I am in a notebook. I'm going to make it a bit bigger. Whoa, too big. I'm going to make it a little bit bigger. So you can see over here, of course, there we are. I can run some Python code. That's what you'd expect. I can do some imports. Let's actually just check if I have some stuff here. Matplotlib. Okay, great. We can do some things. So what I can do here is I'm going to show you quickly. Here I'm in the cell. If I press escape, I'm now in kind of like an editor mode. If anybody here uses Vim or any of those sorts of things, it will be totally natural for you. But now I can say A, and it'll create a cell above. And I can press B here, and it'll create a cell below. And this seems dumb, but it's super quick. It makes your life very, very easy. And importantly, the most important one in staying with the theme of keeping your notebook clean, DD deletes a cell. So just go into this little command mode thing, out of the cell with escape, DD, oh, it's gone. That's so good. And it's gone. Okay, so learn these shortcuts. They're fantastic. It will make your life a lot easier. You can undo cell deletes. You can save and checkpoint as well. So you'll notice, of course, you can do this from the little drop downs, but that's a little bit slower. Okay, so that's not that cool, but
Quickly go back.
yes.
So are you going to edit mode? I think you just press escape, right?
You just press escape, yeah.
So whenever if you're editing, from editing to the other mode, to escape.
Yes.
That helps.
Oh, we got a heart on Vim there. Yes, let me, I'm with you there, Chris. Yes. Okay, so it's everywhere. It's so nice. You go onto a machine and there it is. Okay, so I'm going to look at these guys, though. These ones are a little bit more powerful. So there are magic symbols pretty much baked into Jupyter. There's a couple of really simple default ones. You can create your own as well. So you can write your own custom Python code that'll get executed upon using one of these magic symbols. So I'm going to grab this one, this config completer use Jedi equals false. It's awful. I Stack Overflowed it one day, and I copy and paste it in every single one of my notebooks now until one day it's normal for a notebook. I don't know why it's not normal, but it will do all of your autocomplete stuff. So let's go like this. I'm going to import pandas as PD. Okay, so pandas is that data frame stuff. I know this, maybe you guys in the deep learning side aren't using it that much, static frames, but it's really great. And I'll create a little data frame for myself here, df equals, and it's pretty plain. And I can say df, and I'm hitting tab now, hoping it will autocomplete, and it's not. I don't know what I can do. I don't know what I can do on that particular object. So of course I can do things like this and go, you know what, let me say dir df and list all of its attributes and functions, but this is a nightmare. You know, this is no way to work. So I want my autocomplete on, and sadly I do it like this. So I use the magic symbol, I say that, and now I say df tab, and there you go. There's all the goodness. Okay, so that's a good one. You want to keep that one in the back pocket, and if they've released another way of doing that, please let me know, because that is pretty annoying. Okay, there's a few other ones. If you're working in notebooks and you're doing analysis and research, you're definitely probably using the matplotlib inline. That's another example that puts your plots directly inside the notebook for you. Yeah, you can even list all the magic symbols. That's quite handy. Let's quickly give that a little go here. I'll drop that in there. And here are a bunch for us. RM, move, LL, and so on. Okay, cool. So I'm going to get rid of that one quickly. Let's go back. I will jump back here one more time. But there's a few here that are pretty handy. And I've just put down the ones that are most commonly really used if you're trying to do things a little bit quickly. So this %env is the environment of the notebook. So the notebooks are typically running in a normal computing environment, and underneath there is things like your bash terminal and stuff like that. So if you guys have been working in Colab, you know what, I'm going to go to Colab and just create a new one quickly, just for fun. Let's say new notebook. And let's get this guy spun up.
So we do actually have a question which popped up here.
Yes.
And the question is, in Google Colab, I often have to reinstall the packages each time I reopen the tab.
Yes.
Is there a way to not have to download these each time I open a session?
Oh, that's such a good question. So I actually have never tried to figure that out, because usually the work I do in Colab is short-lived. So I do have a colleague who mounted a part of his Google Drive into the Colab notebook permanently and used it as his own persistent store.
So the big reason.
The problem is it's transient VMs underneath you. So Colab, when you start the Colab session, you get some sort of ephemeral compute. In other words, it's got a short lifespan, and whatever's in there gets destroyed. And once your 12 hours runs out or your usage drops, and they cull that compute for you, it's gone. So you need to start again. Yeah.
So what he did was he mounted his drive,
Google Drive. Yeah.
and that is his storage.
Yeah.
Which then works. And so everything is saved. You can actually even save, I guess, everything in Google Colab, and then it should be available
Yes.
within the drive.
Yes, exactly. I think I have a link here, sadly, that I probably clicked on somewhere in the past. No, I haven't. But anyway, yes, you can mount it in. That's the way you do it. And then you have a permanently persisted backend for your Colab. How that would work though with the Python kernel and the interpreter is another matter. You're going to have to do some trickery with the paths and things, but it's totally possible. It's totally possible. Okay, so just quickly, I'm going to look at a few of these that are pretty useful. So, of course, the matplotlib inline is pretty darn useful. The autocomplete is, can't even say very useful. It's exceedingly, massively, incredibly useful. And then, you know, loading and reloading modules is something that you're going to do quite a lot, particularly if you're following this kind of approach. So it's quite common that someone would, you know, define like a, let's call it, I don't want to say some, that's a protected word. I'll just call it my func. Okay, and I'll pass something in here. And, you know, maybe I'll just print that thing. I'll be very unexciting today. There we go. And I got some function and I decide, you know what, this thing, it's always in my notebook. Maybe it's much longer, much bigger. And I'm going to keep kind of reloading this. And also, I might have some sort of variable in here. Maybe I want to say v equals, you know, x times 2. And it turns out that somewhere here I created an x, right? So now I can say my func 2. Well, that's a dumb number. Yes. There we go. So there you can see that little annoying shadowy thing that I showed you in the slide earlier, right? Because this function is now quite happy, but this makes no sense for this function. So if I was to say, okay, cool, you know what? Let's say maybe this is a little higher up. I'm going to keep, every time I run the notebook, I'm going to have to keep rerunning that function. So I'd rather persist it, you know, underneath me. So I'm going to just say write file, and I'm going to call it utils.py. You know, maybe I've got a few of these things. I'm going to do that, and you'll see it popped up on the far left here. I'm going to click on that, and there's my function. Magic. Okay, now immediately you'll notice there's a few problems. Those problems are, firstly, it's got no imports. I needed to add them here if it was critical, right? So you need to be a little bit careful. But the nice thing now is that's gone, right? I can now delete that cell if I wish, and I'll do that. And now I can just say import utils from now on, and it'll be there, and I can say utils.myfunc, and I'll say 3, and it'll freak out because, x is not defined. Well, that makes sense, because now I've got rid of that annoying dangling state that was kind of always in my notebook, but now it's not. Now I've isolated it just to the function. So that's good practice, makes good sense. I'm missing a variable here, darn it, and I'll add that back in here.
I think this is probably a good point to mention that whenever you can, it's probably actually good to move code out into libraries.
Yes,
for reuse.
Absolutely, all the time. Yeah, you kind of want to see your notebook as a thing that you're tending. It's a garden you're tending continuously. You don't want it to get a little bit insane. You want to keep it nice and clean. And you know, something that you've really wrangled and gotten control of, you want to move that out and keep it trim. Keep the notebook simple, focused on what it is you're trying to do, right?
I was going to say it's like basics, but it's not basics. It's like there's this discipline, everything.
It is difficult to maintain the discipline, yes. And I mean, look, ultimately, if you guys are doing, you know, you're doing number crunching, you're just trying to get some results, you're trying to understand plots, you think it's going to be useful later. So it's not so simple in an analysis workflow, yes, right, to do these things. But once you know you've got a function, I saw, for example, I did a code review the other day with a data scientist who wrote their own custom version of a MEP, absolute error measurement on time series. And there were 3 or 4 of these things. And basically those functions were done, and we could just shift them out into a lib, import that lib. We could even test those libs, right? And then that was just pulled into the notebook. So anything that you want to reuse, you're going to move out. Cool. Yes, you can pay for Colab Pro, 100%. Yes.
No, if actually it's available in South Africa.
I just Googled it, and
I think it is.
Okay, so a post from 16 February 2020 said it's only available in the US and Canada.
Hey, okay.
But it's a year later.
We're not using it.
Nailed it, that person. Good job. No. Okay, cool. So yeah, so anyway, so now I fixed that. So let me just take you back to this little story. Of course, my notebook is called Untitled. That's very poor form. You always want self-documenting code if you can, particularly if you're collaborating with people. So I will call this Indaba, and I'm going to call it 1 because that makes no sense. No, I'm kidding. I'll call it Indaba Magics. Cool. So I now have changed the function, but of course it's been imported to the notebook, so the notebook's not really aware of that new change. So now I can try to leverage this guy over here, and I will drop it in here, and just say it'll auto reload stuff, and it's not working. Okay, this, I can't remember how this works, so I'm going to quickly change. I'm going to say import lib, and I will say import lib reload utils. Okay, and that's going to reload utils explicitly, and now it'll work. Oh, damn, it's telling me that I don't have the other argument. And you can see I can just throw that little question mark there, and times are good. I can see the function definition. So really, I just want to do this, and we're back in business. So you have to do that reload. I messed the magic symbol up now, but effectively that has to be done. If you have a class that's inside this function, then it's a little bit more complicated. You're definitely going to want to reinstantiate the class and so on, right? You don't just get it naturally redone.
So just to recoup now, so as you're exploring and looking at different data, as you're working through this workflow, and you're kind of starting to create some functions, you start exporting those functions into utils, utils library. You import that library back in, and you can then reload it whenever you make changes there, then to further explore in your notebook.
Yes.
And then as time goes by, eventually you're going to package that and test.
Yeah. So I think what's massive, what's great is you can see how we got rid of that weird little shadow variable, right? Which is super important. The more you can move these functions out, the more reliable the whole thing becomes.
And even though it looks like a simple example, this happens a lot because the state is captured in the notebook and you're not aware of that, someone's not aware of it. And then, you know, whenever somebody else tries and runs it, it kind of just crashes.
Yeah, that's right. Yeah. Okay, cool. So you can also, incidentally, if you're too if you don't want to go click on that, you can actually load it into your notebook with. Let me check if I have the magic symbol here before I load myfile.py. Yes, sirree, that will work. So you can go here and say, whoops. Was it 1 or 2? It's 1. Okay, so I'll say load, and it's utils.py, and it pops back up like that. And I'll say, oh, okay, well, I'll edit it here then in the cell if I like. Maybe let's make this a little bit more complicated. I'll say import pandas as PD, and I'll return a data frame, pd.dataframe of this V thing, and I'll run that. Of course, before I persist it again, I obviously want to check that this thing works. So I'll do that and run it, and data frame constructor not properly called. Oh, thank you so much. And there we go. Okay, you know what? I'll give it some columns as well. Columns equals column A. And it doesn't work because I'm trying to be clever here, but obviously I'm not. So let's get rid of that. Let's just keep it working. Okay, cool. So I'm happy. I'm getting a data frame back from my function. I've made some edits to it, and now I'm just going to write it back down. Write file, cool, and dd, delete it. And now if I reload it and run it there, it's the data frame again. Cool. So you see, you can kind of jump around a little bit like this and, you know, get really kind of good at keeping your notebook pruned. Let's use that word. And then you end up really with the core of what needs to be in the notebook, which is, you know, the logical flow through your data, the results that you're getting, and so on. Move out any repeatable functions and use them as imports. That's kind of one of the really handy tricks. It'll keep things a little bit cleaner and more manageable for you. Cool. So jumping back to the slides, if I look here, oh yes, and the last one is env, and I will quickly show you this one. Here you can set an environment variable. So I'm going to say this one for Lydia, you can't see here. This is something you struggle with on Google AI platform. What is it? Google application credentials.
Yeah.
Okay, so Google is amazing. They've got amazing products. And for some reason, they use this annoying environment variable to authenticate you on Google Cloud Storage sometimes. So you would set, you know, your thing here, my key JSON, and then that will be in your environment variable. So now I can actually import OS environ, and I can say Google application credentials, which I'm not going to type now. This might be a little bit much, but there you can see now it's in my environment, right? And you need to do this sometimes if you're using packages that require environment variables. You know, you can't do this. I can't say export for the people in the audience who are aware of how Bash and all that stuff works. If you're in Colab and you're following some Colab examples, you're often going to see this exclamation mark do something. So what that's doing is running a command on the underlying shell. So you can say here pip install something, right? You know, I might say pip install sklearn. I hope it's already installed. Yes, it is, right? But now it's actually just run it on the underlying system. So I can also look at my environment variables here, but those are all on my underlying system, and you'll notice that my Google application credentials are not here. That's because I set them only in the notebooks environment. So the env is pretty handy for things like that. And like I said, there are some packages that require these variables to be set. It's super frustrating. Cool. So that's it really on the magic symbols. You can go and have a look yourself if there's something that you're using, a package that you're using. We use a lot of Google Cloud stuff. Google's got their own magic symbols for reading and writing to BigQuery, reading and writing to Google Cloud Storage, and you can just use those. You provide, like, you know, the table name, the data set, and you'll get a BigQuery table in response. So there's some pretty cool magic symbols out there. Okay, now I'm very much into efficiency on my side generally, so I like to set my shortcuts on JupyterLab. Also, we have a lot of software engineers in our company, and we like to work locally as much as well as in the cloud. It's kind of a progression, you know. You need to be able to dev locally as well, and then you need to be able to push your results out into the ether. So I'm often working on local notebooks, and what I do is I sometimes put this restart and run all command in here. It is super useful because then every time I feel like the notebook's not making sense to me anymore, how is this variable still here? I thought I deleted it. I just drop the entire kernel. So I basically flash the kernel, Control-Shift-R is in, and there you go. Restart kernel, yes, please, all the time, every time. Restart it as much as you possibly can, and then weird stuff like this will happen. Okay, I've got a broken thing. I'll restart again, and I'll run right through, and I expect my kernel to run through. You see, dangling state, right? Look at this. Well, at least dangling cells that make no sense anymore. So delete that, and let's go. Rerun the thing again and again.
You know, I, by principle, restart my notebooks twice every time because the first restart never works. And whenever something isn't working properly or unexpected, I first assume that the notebook state is missing, like wrong.
Yes, that's good.
Then I go look for other
absolutely.
errors.
Yeah, and I mean, this happens often. You know, the brain gets jumbled. This thing is, I don't know, hundreds of cells deep. It's not making sense anymore. But then you might be thinking, oh, hang on, I'm now going to lose all this data that's in this. Well, we should be checkpointing the data as we go along. So now I'm getting ahead of myself a little bit, but that's another really good process that you would follow in the notebook development. So get used to this kernel restart. It is super powerful.
Probably one thing, the voice you guys just heard, that's Lydia. We probably didn't introduce you, Lydia. She's one of our machine learning engineers here at Spatial Edge.
Yeah.
And an Indaba alumni as well, right?
Yeah, I've helped organize it before.
Nice. Okay, cool. So yeah, there we go. So shortcuts, you can go and figure out how to do this. It's kind of in the drop downs. You can get the settings for JupyterLab if you're working locally. Take the time to figure it out. It's worth it. Otherwise, you got to click and restart kernel and click and restart kernel, and it really just, you know, you're not going to do it as often. Okay, so let's get into the meat of it. So we did modern big data analytics, Jupyter, and Python, and now we're quickly hopping into this whole story of reproducible. So there's a whole bunch of definitions out there that people argue about. Is it replicable or is it reproducible? So we're just going to go with this one. Computational scientists generally use the term to answer the first question, which is that you can check the research with the data, the code, and the method of analysis. So if you have access to those, you should be able to get the same answer. We should be able to reproduce it at least. Okay, so that's kind of what we mean by reproducibility, and that's the goal really, right? I want to share my notebook with Pio or with Lydia, and I want them to be able to contribute to it, and we want to be able to have meaningful conversations about the additions that they made without getting stuck in, you know, confusion because they're getting different results than I am at the start. You know, maybe they get the notebook, they run it, and it's immediately different, and now we're all kind of confused, right? So you kind of want to get that out of the way. So let's have a look at some necessary conditions. to get to this whole reproducible point. So you want to version all your code, right? And you might be using some other tools that help you there, but if you want to learn a good skill, if you're going to be working in this area anyway, Git is just pretty darn handy. Okay, but you want to version all your code. You also want to version all your data, right? And now you might be thinking, oh, I need something complex, like this nice guy over here on the far right. That's a picture from DVC, which is a version control tool, and it does all your stuff in Git for you, actually. You don't necessarily need something so complicated. You can start today by having a decent convention, right, for naming your files and checkpointing your data. So don't let this hold you back. If you don't have a nice fancy data version control tool, then you need determinism. And I mean, if in research this is quite common, you're always going to set your random seeds. If you're doing simulations, you always want those simulations to produce the same results with the same seed. So I think you guys will probably get that if you're in the research area, but determinism is quite important. And just quickly here for fun, it turns out you don't really get good determinism of GPUs because there's a lot of non-deterministic weird stuff that happens between all those cores and floating points.
Yes, operations.
Yes. So here you're already at a little bit of a disadvantage, but usually these fluctuations can be quite small, so you can take a much more statistical view really as to how similar things are. Also, for fun, if you are using distributed data sources underneath your application, there's no guarantee as to which data arrives first. So that's another fun thing. So if you have lots of partitioned Google Cloud Storage or S3 bucket data, or maybe you have a partition. So what I mean by that is, these data sets are so massive that they span multiple machines in the cloud. And, one machine might return before the other one this time, and the next time it's the other way around. So you're always going to get different order to your data. That's another freaky one. So we have data engineers at Spatial Edge as well that work just with getting the data into an appropriate format for data scientists to work. And one of their processes is as well, if they get a large SQL query, can they on some subsample reproduce it? So they would order some of those data first on the source and then take a sample. So it's a costly exercise, but at least you are getting the same data every time, and you can at least prove to the person who provided the SQL to you that you're starting on a solid basis, right? Let's take this SQL now further and further work on it. So it's not just data science that we're touching here, it's also data engineering. Okay, so determinism is pretty darn important. And then you kind of want to track your dependencies, right? It worked on my laptop, why is it not working on yours? So it turns out that we have a different version of Keras or XGBoost, and I've got different features to you, and you're getting a different result, and that is super common.
Wasn't there even I remember there was a story about XGBoost where was the same version but different compiled in different environments, and it then also didn't reproduce the results exactly.
Yeah. There were different C headers underneath. This stuff is complicated. It's complicated. Okay, cool. So these are basically your necessary conditions. You need at least this stuff. You need a good dose of common sense as well on top of that, so you can keep your notebooks nice and clean, but you need at least this. So let's jump into the first one, versioning your code. So commit all relevant code, or you can use some kind of collaborative platform. That's where you got to maybe throw money at the problem or something like that, but we're big proponents of use open source now, tomorrow, today, just get started. You can at least figure out how these things work and what it is you need. And then you can see what the shortcomings are. But for this, we pretty much just use Git. So there you can see it, but just really use Git. Just get started on Git. It's going to be worth it. If you look on the far right here, actually, you'll see that this is a Git diff. So I don't know if you guys are familiar with Git there. I guess most of you are, but I'll quickly jump in here and make this a little bit bigger. So here I have a repo. And I'm just going to quickly do a Git status. Nothing has actually changed. So let me change something. Okay, and I will go here, hello world. Cool, and I'm going to write quit there. Oh, and to the Vim fan, I can't remember who it was, there's some good old-fashioned Vim. Okay, cool, and if I do a Git status, of course you can see I've changed it, and Git diff, there's my new line. Okay, and if I was to make a modification like this inside a notebook, the consequences are far less pleasant. So we'll have a look just now, but this is actually a notebook that I changed. So here you can see a nice little change. I actually changed the last element of that list from a 0 to a 1.
I remember this is actually one of the main reasons not to use this in production, because
In 2017.
it's super difficult to
Yes.
version control.
Yes, version control used to be quite difficult, but the community is super active. So there's a lot of really cool stuff that people are contributing all the time. So here's some Git. We're going to look at how we can use Git with notebooks now when we get into the tutorial session. I see it's 3 o'clock. We were asked if the whole 2 sessions will be used earlier. Let's see how we get on. Looks that way at the moment. Okay, cool. So versioning your data. So you can kind of do this in a very practical way immediately. You can, I'm calling it low level, but you can really just have a couple of conventions, right? Have a couple of conventions around the way you name your files. You know, we have this joke in the company that the file is like final _ final 2 or whatever. You know, you generally tend to see that quite a lot in people's notebook code. But you know, you can have a sensible way of naming these files, any data files that you're kind of pickling or storing. And if you do that in a consistent way, then you actually have a history of the various experiments that you conducted, even on your laptop. And if you're, you know, lucky, you can work in the cloud, right? And then again, you can just use some conventions, right? So on Google Cloud Storage, on Google BigQuery, for example, you can use shards, and shards are date timestamps. So you can basically have these different partitions of the data in the cloud, and they'll all be named according to which day it is you push them in, right? So you can do that. You can even do it on a finer grain if you like, and you can start that, well, if you have a Google account, you can start that tomorrow. You get $300 for free, basically, actually, but you'll burn through that quite quickly if you're using shards. Okay, and then you can do partitions as well, and then, you know, in the partitions, you can have lots of new partitions for new experiments if you're generating lots of data, or you can just use file paths, right? And we actually do this quite a bit. I'm just going to see if I can find something. I'm going to make this a little bit bigger as well. This is not the right project. Okay, let me not do that. I don't know what's going to pop up there. Okay, but we do this quite a lot. So we'll name, it's just a normal Unix path, and you might have a convention there. Like, you know, for example, we would have a model creation date, we would have a run date, and you would date timestamp these things up to the minute if you like, right? So you can actually just store a litany of these things underneath you as you're working through your notebook. So long story short, you can do this tomorrow, just start working with it immediately. Otherwise, you can use tools like MLflow. These things are metadata stores. It'll keep track of your experiments for you. It's a really great tool. We use it over here on our side. And then you can also use DVC, which is also going to be doing your data version control for you. You can go and check them out online as well. They seem pretty straightforward to get going. But really just get started. You know, that's the thing. Just start tomorrow. You're going to be thankful later on when you had this really great experiment 10 experiments ago and you can't remember how you got there. Okay, cool. Then the other thing we said was you need to kind of worry about dependencies and the environment. So if you're working in Python, package management is super important if you want to collaborate with your colleagues or your fellow researchers. So the idea here is you definitely want to kind of isolate the dependencies required to run the notebook that you're currently sharing with someone. If you're working in Google Colab, it's not going to matter that much to you because you're kind of spinning up a brand new machine. And, you know, every time in the beginning, you can see it from any of the tutorials you do in Google Colab, you're always doing a pip install something, you know, and off you go. And you, as someone's already pointed out, you know, the next time you log in, you got to run the whole notebook again. What's nice, though, is because it's ephemeral, because it doesn't really store the state beyond that point in time, at least you know you don't have any of this dangling stuff. And you're probably following a nice approach there, because you're being forced really to restart your notebook. But this is tiresome, having to rerun stuff all the time. But if you're doing it in Colab, you're not going to notice that this is it needs to be kept track of because you're kind of implicitly keeping track of it inside that Colab notebook. But if you're not working in Colab, then you really do need to keep track of it. So we do that using sort of package management tools. You're effectively, anyway, when you're doing a pip install, you're just pulling from PyPy. And then over here, and the next slide here, so all we're saying here is we use virtual environments. You can use PyEnv, there's Virtualenv. There's a whole bunch of options for this in Python. You know, it's a good idea to familiarize yourself with them and get used to using it. So the kernels you see spun up over here are all kernels that I created with Virtualenv. actually. And they're all isolating dependencies across different projects that I work on. Here's a Kubeflow pipelines project. Here's a MyEnv I did before this, just to make sure that I still remember how to do any of this. And there's just a stock standard Python kernel as well. So all these dependencies are isolated between the code that I'm working on in that environment, so that I can give it to someone else with the list of dependencies and they can go on. Okay, cool. So this is definitely a current best practice approach, and it leads you definitely to having reproducible and shareable code. What is this example here? Yeah, unnecessary. I've already shown something, and basically this is just a kernel, as I've also shown. So we can show you how this is done very quickly, and you can see it here. We basically, I'm a Unix user, so I'm a Ubuntu user, so I'm going to apt-get install my Python Virtualenv. I just create the thing. Here's a Docker Hello World example that I was working on. So I isolate my dependencies inside that environment, and then I can effectively activate it, and then I actually install Ipython so that I can create a kernel, so you can see that in my notebook over there, and then my kernel's installed. So what I would then do is collect any dependencies there so that I can share it with people, but we'll talk about that now.
You can pip install Virtualenv as well.
You can also pip install Virtualenv. Correct.
Can I quickly pause you and ask if you can answer these questions that they've
Yes.
Okay, so first one was if I want more powerful computation, for example, to do intense computer vision tasks. You know, that sounds intense. I've used free Google Colab with GPU. How can I take this a step further with a free or cost-effective option?
That's a good question. The free is tricky because Google Colab, you get those GPUs attached, right? And I mean, that's free and it's fantastic. But if you want proper compute, generally you have to pay. So I mean, I actually, well, I mean, we work on Google Cloud Platform and AWS and things like that. So for work, I don't have to pay, but in my personal capacity, I did actually sign up for the $300 free. So Google Platform will give you $300 for free. And I think I still have a positive balance, but I haven't been burning that much through GPUs. So Emil, you might be able to, I don't know how far $300 will get you, but at least there you can access some pretty good GPUs and TPUs actually on the platform, which are quite a bit cheaper. So, but I'm afraid I don't have an answer for the free side.
I want to add one of our someone else at Spatial Edge is doing his PhD, and he emailed them and asked if he could. He said that he was a PhD student and he needs more compute power, and they actually
they gave it to him.
They gave it to him.
Nice.
On his Google Colab.
I'm not sure.
Or just
probably on his Google
but
account.
he said they replied very quickly, and they called him to hear what his story is about. So they were quite interactive.
Goodness.
It was Paul.
Okay.
So basically just maybe reaching out to Google itself and be like, look, guys, I want to do some interesting research. Do you have some spare GPU capacity? That sounds cool. All right. Then the second one there.
Okay, the results of my analysis vary considerably depending on the order the uniform data came in. Does that not mean my analysis lacks robustness? Yeah, look, I mean, that's tricky. I wonder, it sounds like you might be working on something a bit more on the sort of streaming side there, but I mean, depending on how you're working, order. Yeah, so we're going to do that quickly in the tutorial. I don't have the context from your question, but if it's something that's kind of fixed once you've done it once, we generally try our best to set all the seeds we can depending on the environment we're in. So NumPy's got a global seed you've got to set. Python itself's got a global seed, so you should be able to generate the same data from that starting point. But yeah, I mean, I wouldn't say it lacks robustness. I'm sure you're being robust in other ways. I think it's just not necessarily going to be deterministic, right? If you're not fixing those seeds. Okay, then the other one isn't recreating environments unbelievably wasteful in terms of energy? The packages get pretty darn big. So I think the Google Colab requires you to have a Google account, and the storage backing underneath that Google account, interestingly, is your normal Google storage that you get for free. And I think everybody gets 10 gigs or 20 gigs for free on a Gmail account. So that's actually what's underpinning that.
But I think in terms of also the energy being used, it would be interesting. It's kind of like almost like
I think the GPUs are getting you more than the packages are. Though. Yes.
But yeah, if you're running obviously compute, I guess this goes almost into the conversation of how Google itself is. I guess.
Well, I actually saw an article a couple of days ago where Google claimed they have some. They say that they're almost at zero for. They recoup the energy that they spend. They say, they say so. I didn't read through. Okay. Don't quote me on that. I don't want to quote a headline. But yes, I mean, I think what's interesting is if you work in the cloud environments, there's a lot of this preemptible stuff that's happening, and that word is an interesting word that you might encounter if you're working in bigger distributed systems. And what that means is instances or VMs or anything that's not being used gets recycled. I mean, effectively, those machines are running all the time, really, right? But if a user is holding onto it and they're not actually using it, it gets recycled away from you. So that's actually how Colab works. That compute gets repurposed.
So basically, if I have preemptible machines and not using the capacity, that gets basically physical or the virtual. It gets shifted over to someone else.
Yes, but ultimately that machine's running the whole time. But it's just that it's being used more.
Someone else using it, and then when I want to use it again, a different machine will come my way, and then I can use that capacity. Yeah. So it's being distributing the load.
Yeah. Is there more?
Yeah. Your thing's dying.
Cool. Okay, cool. Yeah, thanks for the questions. Keep them coming. I think, so just quickly then, this is on the environment. Yes, and they do get big. I actually tend to cull mine quite regularly as well, just to keep things a bit clean. So let's look at determinism.
I think your camera might have died, actually. Funny enough. I think oh, wait, no, you're back. You're back.
Okay.
There was just a moment.
Great.
Cool.
Okay, if there's any problems, do shout.
Will do.
Okay, so let's look at determinism. So I'm saying set seeds always. And you can solve most of your problems with these two lines if you're working in standard Python. So, you can basically import random, which is the built-in random number class for Python, and there you can set the seed. So here I just set mine to 101, but that doesn't cover all cases because it turns out that if you're using pandas or something like that, it's using NumPy, and NumPy has its own seed. So you've also got to set NumPy seed. And I think you were saying that with GPUs, there's also two different TensorFlow, yeah.
Global, and you've got
you also got to set independent seeds in TensorFlow. So you just want to be aware of what it is you're using, what package you're using, and just make sure you get those seeds set. And then at least you won't get too much variability. There might still be some small variance, particularly if you're using GPUs, but you're probably going to have near close to identical results otherwise. In this case, for the kinds of workloads you do in pandas, you always get identical results because that's pretty much static data and it's pretty simple. So this is a useful little snippet there. Try and get those guys set. And then sometimes inside the model APIs, you might also need to set a seed. And it might be overkill because it's using, maybe NumPy or something anyway underneath. But XGBoost is a C library. It's a little wrapper for a C library. So you never know what you're going to get there. Oh, this is a gradient boosting one, sorry. This is the train test split. And there we're setting the random state. And I can also set it on the gradient boosting classifier. So yeah, you can be heavy-handed with setting your random seeds, and then at least you always know the notebook's going to produce the same result. Cool. Okay, so determinism was the other important guy there. So I'm just going to scroll up here quickly. So we basically said we wanted a version all code, version all data, track all dependencies, and then, of course, try to get some determinism in place in your application. So let's go to the last section, and that's looking at a workflow or approach to a workflow. I think we've really given the whole story away as we've been going, but let's jump in and have a look at how this, let's say a shoestring workflow would work where we don't have to go and throw money at big tools. So just to remind you of the principles, we don't want to suckle, so we kind of want to just get some data science out. So use your magic symbols, make your life easy. We want reproducibility, so set those seeds. Collaboration is not on here, but I think that's captured in the close to production part because you don't want dangling code and unnecessary stuff in the notebook. Importantly, if you're sharing results, you absolutely want your graphs and stuff in there, right? Absolutely. But you don't want information in there that's going to detract from what you're trying to do in the notebook. And we see this quite a lot, that someone will keep a bit of code there just in case they want it later, and then 3 or 4 merge requests or reviews later. No one's really sure what that code's doing. If people are constantly asking what's going on there, what's that code doing there, it's better to keep things very, very clean. And then the other one is to be systematic and approach it in a sort of a staged approach. And that's because you do want to checkpoint your data as you move through, particularly if you're going to keep rerunning your kernel the whole time. You don't want to have to re-download data, right? So there's some kind of a directed graph that you're going to build up.
I told him maybe know that I think keeping it systematic is just a lot easier on your brain. You're going to have to remember a lot of things. Because if you've got a massive notebook with 300, 400 cells, it's a lot of thing context. Like if you move that out to libraries, it's a lot less to focus on.
Maybe all you guys in the call can tell us how long your notebooks get. But I've seen some pretty big ones. They can get quite expensive. Okay, cool. So those are the principles, and that's kind of what we try to stick to. But let's have a look now at that last systematic one. I don't think we've really discussed it that much. So the DAG one, and here you can see a model lifecycle if you're doing stuff in the data science world.
Horizontal, you can zoom in on the
yes, thanks, Pierre. There we go. Okay, so this is taken from Uber Engineering. They've got a nice little diagram here. There's lots of people who have this diagram. If you're doing anything as well, what's the other one? That's the crisp DM method with the data mining approach. Get the business requirements and so on. This is the same story. So let's start at the very top. So here you have understanding the business needs, define the minimum viable product. So here, step one is define some stuff. That's some meetings. If you're a practicing data scientist out there in enterprise, a couple of meetings and understanding your customer a bit, and then you're going to get some data. And once you got that data, you go into this loop of prototyping where you're doing some data preparation, you're doing some model fits, you're doing some evaluation, and then you need more data. Okay, so you're going to keep going a lifetime's worth of code in one notebook. That's extraordinary.
I would actually love to see that notebook.
He never restarts the kernel. Or he never restarts the kernel. Cool. Okay, so yeah, you're going to go into the cycle of, I need another feature. Let's keep training. Let's try and figure out what else we need. And then when you're done with that prototype step, you get to this, productionize step. And let's say for the sake of, people who are doing research here, that step can have another name as well. That can be like sharing it with your collaborators, preparing it for publishing or whatever else, right? There's a step where you've got to do some serious cleanup, some serious questioning of what's going on in the insides of that notebook. For us in enterprise, that's productionizing it. It's a lot of work that we put in to automate it and make sure that the right data is flowing through the pipes and that the results that come out at the end are trustworthy. We will then deploy these models. So we'll put them up there as a service so that they can be called. They'll make predictions. In ML engineering, you need to monitor those predictions. You need that feedback loop. How do you know this thing's actually performing well in the wild? And then you will need to do the further analysis on those data and figure out, do I trigger a retrain? Is the model getting stale? And it might, not all methods are nice online methods that are just updating themselves. So you have these jobs that have to get triggered for retrain. So this is the sort of the cycle you go into. I'm going to go back here and see. So the first thing, though, that you're probably going to be doing in this small prototype loop is a lot of exploratory data analysis. And that is where notebooks get super messy. And that's where you kind of need to practice a lot of this discipline. And then when you get to the production, we're going to pare it down and make sure that it's very, very clean. And then ordinarily, we actually would like people to check that notebook out again and make updates after it's actually gone live. So the thing is a living piece of code, right? It's not something that's, I've done it now, I'm going to make a PDF of the notebook, I'm going to send it to you, and our work is done. It needs to be able to run, it needs to be able to be adapted to things that are changing in the problem space. And then, of course, we can now logically partition. So if you have a look at the diagram there, you can see the Uber Engineering is making it easy for us here. Everybody has their own categories. We do too. But here we have get data. Here we have data prep. Here we have train. And here we have fit. So you already have 4 potential stages you can break your notebook into. The nice thing about this is once you get data, you want to persist data so you don't have to get data again, right? And then once you've done the transformations, maybe you're filtering, you're joining, you're dropping, you're doing all of this stuff, you're cleaning, you're going to persist, right? And then you're going to read that data up in the next notebook, you're going to train your model, you're going to get your parameters, your fit, you're going to persist the results as well, And then if a neural net, you're going to persist all those weights. And then you're going to evaluate the model on a score set, on a holdout set, and you're going to persist those results because you need to share those results typically with your collaborators or whoever else.
So persisting it throughout this entire life cycle.
Yes.
That makes your life easier.
Makes your life easier, makes things safer. Yeah.
Because anyone can go and look what was it at that point in time. It's not like it was in memory and then lost after the
yes. Or I get your massive notebook and I've got to run the notebook top to tail to get all of these stages executed, and then it dies on the 99th line, right? And then and then we're not quite sure. At least in this way, I can interrogate and go, okay, well, where might the problem be? It's the previous stage. So let me check the previous stage's data. Yeah.
Okay, cool. And just out of interest, if you're persisting the data throughout that life cycle, so does that mean like the person can only should be able to only run the last cell, but they still need to go through all the cells?
I'll show you an example now in the type thing. So it would ordinarily mean that if a get data notebook is getting data and just kind of prepping it and then pickling it to your file system, then that stage is complete, and the next stage will just read that pickle up and carry on. Is that what you mean?
Yeah, 100%. It's like a checkpoint.
Yeah, it's a checkpoint, 100%. It's a checkpoint. Okay, cool. So let's have a look here then at a common set of stages that we see very, very often. So here we have a prepare, fit, and evaluate, which I've already kind of really drilled into on the Uber one. And then over here, you would see each of these stages we would write out. So the prepare step would be doing some data munging, and we would persist it. The fit, we would persist, and the evaluate, we would persist. So all of this stuff is kind of measurable and testable and shareable. Auditable, rather. Measurable, auditable, and shareable. Okay, cool. So let's finish off then with this last slide. I've been talking so much, I apologize, and then I'll quickly hack at some code, and then you can see we make lots of typos. But tips and tricks. So really what we're saying is restart your notebook often. This is going to be pretty handy, and it's going to force you to restructure your notebook in a way that allows you to restart it often without losing too much analysis and exploration time, right? So you're definitely going to get smart about how you do stuff if you have to continually restart it. It also means that you're not going to have some weird variable in a sub loop that was set out in cell 9 and you're running in cell 100. So restart your notebook often. Dangling state is your enemy. It's bad, bad, bad. Checkpoint your stages to save time. So we've got that one as well. So you want to persist your data to local files if you have to, right? Just start today, start tomorrow. You can persist to share storage if you can. That's obviously ideal, particularly if you're collaborating on work with other people, then they can also access it. There might be, incidentally, there might be a temptation here to persist your data into Git. If you have really, really small data, then I would not caution you against it, but generally that doesn't work because, it's not, Git's not made for that sort of thing. And you're gonna have trouble Git cloning those repos after some time. It's going to be a nightmare. Each of those diffs will change dramatically if you're making lots of transformation changes. It's going to be a nightmare. So I think the principle rather to follow is from cradle to grave, from beginning to end. You need to be able to pull the data and reconstitute it as necessary. Cool.
Okay, there's one question.
Yes.
What is the best practice for automated testing on machine learning pipelines? In other words, how would you write integration tests to catch issues with some stochastic models before the change gets to prod?
Cool. Now that is a good question because there's so many approaches at the moment with automated testing on pipes. We do ourselves quite a lot where we check against baselines, regression sets. Like we've got a whole bunch of things that we typically check. I just want to get the second part of it. How would you write integration tests to catch issues with a stochastic model before the changes get to pod? So what we actually also do is we have ingress checks and egress checks that we always apply, but on some of the distributions we do check. So we might be checking some of the moments, the kurtosis, it depends, but actually the one we use the most is decile bins, and then checking how the shifts in those bins occur, to see if there's a smoking gun somewhere. So very often if the score distribution of your model changes dramatically, then you have some issue further up the pipe. So if you're doing this for the first time, you want to start out by focusing on kind of maybe that most important stuff. And then as you work your way back, you can check drift in the training data and so on. but ordinarily you would basically be looking at those distributions of the data itself. And that could be on an attribute level if you're looking at the features, but on the predictor level, it's going to be on the score distributions themselves.
I also said that's for the pipeline during training.
No.
That's all the time.
All the time.
All the time. So if something changes, you'll
all the time.
Yeah.
Even when it's in production, as it takes the step over into production, all the time. You're constantly evaluating those shifting distributions. Constantly, yeah. Okay, cool. Okay, persistent share storage if you can. Okay, and then librarify as you go. And I think that is the last one. So these are all the things we went over now quite quickly. I think I did jump now into some of the notebook stuff. So at least we've done some hands-on tutorial goodies. Now we'll do the next one.
Is that a word?
No, I made that up. I don't know, maybe it is, but I thought I made it up. But let's see. Okay, so let's hop over into some hands-on goodness. So just quickly, this is actually taken from some Google Docs just for fun. So you can see on the left here, useful notebooks that are building models / dashboards / etc. And then here we have production-ready code and weeks, if not months, in between. Yes, this is the case. We've seen this quite commonly. There's a lot of research out there saying numbers like 9 months. If you're a bank, it's even more than a year. Some of these things are super challenging. We, in what we do, have gotten it down to, if you follow the good process and the tools that we have, to a few days. So you can do this quite quickly. It's pretty much something that we do as a core capability here. So I don't expect you to do it tomorrow, but this is kind of what you want. So, you kind of want some sort of overlap between the amount of work that goes into EDA and how quickly it's ready for the production use cases. So what we do over here is we actually typically build lots of libraries that make that easy for us, and we give those libraries to data scientists to work with while they're busy working. So that's kind of the way that we get things to go a little bit quicker. But that's what we mean with taking these things into production a little bit more quickly.
You said it quite quickly, but that's a good point. The libraries are there already. The same libraries are in production. Yeah. That means that the service that needs to change is very small.
Yes.
Therefore, you can also a lot quicker to review, a lot quicker to see what's happening. Before you go on, there's actually another question that popped up.
Yes.
So, do you recommend object-oriented programs written in different notebooks and then running those scripts within a single notebook? Also, I often see for experiments a config file that changes inputs for certain experimental settings.
Yes. Yes. Okay, great. Yes. So we, on our use cases, also might have lots of models with different configs. Configs might be different in different environments as well, depending on what you're doing. So for that, we often have specific configs, and experimental configs we actually do have as well in some of the models to try different starting points and so on. And those will, in fact, get committed. They're simple YAML files. It's very straightforward. And you'll read those things in, and each pipe could, in theory, have its own config, right? So an experiment is a pipe. It's a DAG. And you'll have that in your let's say you're doing it in Python. You'll have a Python package for that particular kind of experiment with its own config file. And you would very often reuse maybe some of that code across a lot of those experiments, right? So there you would be using libraries. If you are saying, I just want to check here, and then running those scripts with a single notebook, yes, I have seen that. And as a matter of fact, I have one of those open here called driver.ipynb.
Just out of interest, would we recommend object-oriented programs?
Well, Python is pretty chill, so ordinarily a lot of our stuff is like that, just naturally. Yeah. I mean, there's a lot of cool benefits to doing it that way. I mean, if you can extend sklearn's model classes, then you can throw them into sklearn functions quite easily, and life is good. If you've got to write a lot of your own custom stuff, it can be tricky.
I have to follow more functional approaches. But that's why I'm not coding it.
Yes. So interestingly here, you can see I actually have what you might call a DAG of sorts. So here you can see I've got a couple of notebooks. So I'm actually being a bit sneaky here, and I thought if there was time at the end, I might show this, but let's show this now. I think it's a good question. So we took a use case and broke it into data prep history. So this is get my historical data. Interestingly, you can see here, I'm running a thing that initializes the environment, but importantly, these are some interfaces, custom interfaces we have here. I will basically just say, hey, pipeline, get me my sources. And it will go and get me my sources, and they're all configured as YAML for this particular pipe. And then I'll do some transformations, and then I will write my features. And this write features is actually writing to Google Cloud Storage. And here you can see an example of that path I referred to. So we have a nice little convention. It's a little opinionated thing that we do where we say if there's certain things that are set, we will compose a path for you and so on. You can use MLflow to do this stuff as well, but this is a very, very quick and easy way to get it done. And then this just reads data, does some initial transformation, and you can see my transformation has already been moved out into code, and it looks like this. Very, very simple. This guy is used in the preparation for training as well as the preparation for scoring, right? You kind of want the same transformation, otherwise you're going to get weird test and train skew. So you want the same functions executing that logic. And then over here, no, this doesn't look good. I'm pulling in the same transform over here. So I'm using that same bit of code in both stages of the pipeline. It's much safer. And you can see I've already moved it out. And I just import it and use it. And then again, after I've done my score data set preparation, I persist it. So interestingly, you might be saying, well, why are you splitting these two things out? But it's not always the case. You're going to retrain every time you want to score. You might want to fit your model on the 1st of January, and it's good for 12 months. You're going to keep scoring, keep scoring. So part of that process is to have those things decoupled if you can. It just makes your life nice and easy. Cool. Okay. So I jumped a little ahead there, but let me show you the driver again. So the driver is really great. The driver is using Papermill, which I think some of the Google guys actually wrote originally, but now it's a massive open source project, which is fantastic. And you can use Papermill to orchestrate your notebooks. So it's actually saying PM execute notebook. I'm telling it run this notebook. Here's the output notebook I expect. So it will actually print an output notebook, and then I can see what the consequences of the execution were. So it's really, really nice. And you can pass variables into the notebook. So you can parameterize the notebook, which is pretty darn great. So we use this quite a lot. Okay. Now, that's all good. Let me quickly jump over. Where was I? All right. So, yeah. Okay, so let's have a look at some of these nuts and bolts, guys, very quickly. Okay, so there's a repo which I made public not too long ago. Let me just check if it's here. Cool. So it's on GitLab. It's under Spatial Edge public workflow notebooks. It's a little bit raw presently. You can see 25 minutes ago, this thing is fresh. But I mean, that's a bit laggy. I'll just reload. But I'm going to quickly just go through some of the stuff here. So,
a shame. Jock still works and actually in the business quite heavily. So putting him into doing this,
it's unreliable. Okay, but here we go. Okay, so here's a section on just kind of getting the environment isolated. Here's a little section on some minimal Git stuff. And then here's a notebook which we can quickly jump into, time permitting now. So, but I've already shown you the answer basically with that other bit. So let's have a look. Let's start with the minimal. I'm going to talk over the minimal environment one. We don't have to do this. You can go and consult this later, and then we'll do the Git one. I think that's going to be pretty handy. Yeah. You're good. Okay. So here we go. See, so yes, I have the use the pip install virtual environment. So you can see this is how you can create a virtual environment. You can also use Pyenv, but I think do try and get that going as part of your standard workflow, particularly if you're working on your laptop, and then you can share the requirements file with your colleagues. Then over here, you can basically, you know what? Let's do this for funsies quickly, and I'll show you how this works. Over here, I have a Docker file, a Docker environment that's busy running. So I'm going to kill that. This guy's also ephemeral, so it's going to die. It's going to cause us some grief. Let me Docker RM this guy. Okay, so for the people who are not familiar with Docker, it's just a virtual machine basically running on my laptop, a lightweight version of a virtual machine. So it's a little bit of compute that's running on my laptop in a nice isolated environment, borrowing from my compute. And then
I guess if you want people to see the commands, you might need to move up the window, but I don't want to break your screen. It's our faces are basically covering.
Oh, okay. No,
if it's not necessary,
I can swap the stuff around. Let's do this.
Oh, there we go. That's perfect.
Terminal is called Terminator, and it's amazing. Okay, so let me quickly spawn that guy. So we'll docker run, and this will give me a fresh environment. So let's go. All right. So you can see the instructions here. Say apt-get install Python 3. This is a Ubuntu container. So I'll just quickly install Python 3. It tells me it can't. So I'm going to apt-get update. I just need to pull some fresh repository data here, and then we're going to do this.
Cool.
There's a little low level, but shout out if this is not fun. Cool. Okay, there we go. All right, I'm going to quickly install Python pip. Okay, and if you're using Colab, it's already installed for you, of course. So that's not too serious. And then I'm going to pip install Virtualenv, and then I'm going to quickly just create a virtual environment. This probably should take just 3 or so minutes, I hope. Come on, not this part, I mean the whole thing. Okay, hurry up. Oh.
It's okay. Cheers, Chris. So this is actually, yeah, she knew Chris. He's studied with me.
That's awesome.
Okay.
Aren't there many people with that name and surname in the world?
Yes.
Sure. Oh, you can see the
I can see
picture.
the picture.
Ah, yes. Okay, great. So there we are. And now I'm going to pip install. I do this user thing because I want to install it on my user, but I'm root, so who cares, actually. I'll say virtualenv. Okay, and in it goes. And I mean, you guys who are running in Colab are used to seeing that sort of thing. And then the command is, I've got to run Python. Python, do I have Python? No, I've got to say Python 3. Yes, I have that. I'll say Python 3, use my module virtualenv, and then I will give it a path. And I will say, I'm going to be sneaky now and do it differently from what's on the repo. I'm just going to call it myenv. It's going to write all the packages in there and put the Python kernel, if you will, inside there, the runtime. And that's it. There you go. You can see I created a virtual environment with Python 3.8. Life is good. And now we kind of want to go into that environment. So I'm going to quickly go to myenv. There's a bin activate function, and I'm going to do that. If you're using a different package manager, like you're using pyenv, then it's going to be slightly different. But I just got used to this. It's a little bit older. Okay, cool. So here I am. So now I can say, what's in this environment? So here I am doing my pip freeze, and there's nothing. So let's pip install something of value. Let's say pandas, for argument's sake. That's going to install NumPy and a whole bunch of dependencies. There's NumPy. I wouldn't do TensorFlow because that'll take ages. That's pretty big. And there's a couple of extra things there that's also being installed. And we're done. So now I can say pip freeze, and my environment's got some stuff in it. So now if I produce code in this environment with this bunch of dependencies, and I share the dependencies with my colleagues, then they can hopefully rerun the code. So I'm going to put this in something called requirements.txt. This is just Unix for redirect the output into a file. And if I look at the contents of that file, you'll notice it's all in there. So I can actually leverage that file now in a way that makes good sense. So I can say pip install, and I'm just going to be silly now and do this and show you how nicely all of this works. It's very, very nice. And, oh, okay, let's actually say yes. Go in there, and boom, it uninstalled everything. So I can say pip freeze, and it's empty again. So now I can just reconstitute the environment if I wish. Pip install R, and there we go. Packages are already cached. I already downloaded them. That's nice, and they're back. And now I can do, stuff again with the libs that are installed. Import pandas, and there it is. Cool. So that's kind of how easy it is. It's actually quite quick to do. If you wanted to install kernels, that's another matter. You need something called ipykernel. So you will just say pip install ipykernel, and then that's going to install the kernel. And that's how I got all these kernels loaded up on my little launcher. So I can actually map that kernel in my Jupyter to the environment underneath. So I know I'm going a little bit quickly, but you can have a look at what's on the old repo there. Okay, cool. So here we show you how to manage the environment. Here's all the stuff I was just talking about. Here you can see the contents, and here you can see the last little bit that we did as well. Okay, so that's how to get the environments organized. That's how to manage your dependencies nicely. Be careful that you need to be in the environment, right? If I exit the environment, okay, and don't worry, you might just do this by coming out and kind of going back in. I'm going to do it like that. and I say Python 3, and I say import pandas, and hopefully I don't get egg on my face. And yes, I did, because I am actually not exited. Okay, I'm going to persist and see if I can tempt the demo gods. Deactivate. No, what else is there here? Is it deactivate? Deactivate NU.
Doesn't look right.
Unexpected token. This does not look right. What is this? This is madness.
Don't you just say deactivate? That's what
I also thought so, but I am going to abandon ship. Okay, never mind. It does work though. All right, cool. Now, let me get out of that Docker container. Okay, cool. So I think we're quite good on the environments. You're going to have to play with it a little bit. There's a lot of cool stuff online to support you there. If you want to get into that, it's not going to be a problem. Let's look at the next one quickly. This one is pretty valuable if you are committing notebooks to Git. And it's absolutely worth kind of exploring quickly. So you can go in here and you can have a look. We talk about versioning your notebooks. We talk about using two specific packages. One's called JupyText, and the other one's called NVDime. This one is handy for if you're doing stuff locally, NVDime. I'll show you what I mean now. And this one is really great for following a nice disciplined workflow for committing notebooks. And I'll show you what I mean there too. So let's have a quick look. If I go back to my other terminal now, that's up here. Okay, I'll make this a little bit bigger. So you can see here, I'm in a repo at the moment, the same repo that I'm busy showing you on the web browser. Okay, I can see now we're behind us again. Thanks for that, Pierre. Am I good? I'm good.
Very good.
Okay, so I'm actually in the repo right now, and you can see here, hey, there's the notebook example, and here's a bunch of stuff. No, that's not where I want to be. I want to be in minimal Git. Great. And in here is a README, and there's a bunch of stuff. If I go to the browser quickly, I'm going to open. I see now I've gotten very excited about opening things, and I've lost my place. That's quite normal as well. Let me close driver. Here we go. That was the Indaba one. No good.
Wait, what are you looking for?
No worry. I'm going to just navigate there. Old school. Okay. Here we go. Minimal env, minimal Git. Oh, so interestingly, I realized I didn't get a chance to chat about this one, but I want to show you this quickly. Here's an example of a pipeline, which is a more production grade style concept. It's much more complicated than this, but let me show you this one. How do I'll just zoom in. Okay, here you go. No, classification pipeline, great, it's actually saved. Yes, but I'm unable to do that. Yeah, you're probably going to say inspect cell now, but I will go up. I will run this rather, and thank goodness. And now I'm going to get egg on my face because it's not going to work, but it does. Hooray! Okay, classification pipeline should be stored.
You're not in the
yes, I see that. Thanks.
You're looking for.
Cool. I'm looking for.
It's not good to get this directory. Pipeline.
Probably not.
You
Okay.
have a lot of files open.
Yeah, I have lots of stuff here. There, documentation technical. Here we go. No, that's not it. Okay, never mind. Not that important. I'll give it one more little go here quickly. Boom, 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 boom. There we go. Tingle Dix. All right. Classification pipeline. Let's open that up. Nice. So this is more of what something like this looks like. So we basically have this ingest stage, we have this transformer stage, and each of these stages there's checkers. They're checking things like the schema, they're checking the data distributions, they're checking the ranges. You know, maybe you're ingesting an age feature and, you know, the age feature is out of bounds. There's, you know, feature stores that are being generated. Here's the train stage. You're checking against history to make sure that the, you know, maybe the metrics that you're using to evaluate your model are in fact improving. You know, so you can swap components in here. You can swap things like MLflow if you wish, or you can have your own custom tooling. And then here's the score stage over there. And you can also check against history there to check that, like that conversation we had earlier about the distribution is changing. You can check against the history there for that. I think this is kind of a more advanced pipeline. They get much more complicated than this. But maybe the fun part here is that this is all done in Python. If you're interested, it's called diagrams.
Oh, yeah, diagram generation. But yeah, there's a little bit of a quicker side there. I think you're still.
Yeah, no, I'm just jumping off there. Yeah. Okay, cool. So Peter's getting antsy, so I'm going to follow his antsiness.
Context. No. Not to be antsy. It's just.
I know, I'm kidding, man. I'm kidding. Okay, cool. So just to get back to the workflow guy, where I was, workflow notebooks and minimal Git. So this notebook is the notebook that's in the repo. Okay, thanks. I'm back on track. And the goal here is to quickly look at NVDime and Jupytext. So if I go back to my terminal, you'll notice, and I mean, you can do this in Colab. You can attach your Git repo, and it will also be tracking if your file's changed. That's the great thing about some of these nice integrated tools. I like my command line, so I'm just going to do stuff here in the command line, but it's the same principles, really. So what we are going to do quickly is I'm going to run this notebook, and that's actually going to change it, really, on disk, right? So let's go and make this 2 and this 2 for fun. I'm going to run that, and it says, oh, not defined. Excellent. Let me run the notebook from the top, and I get that little plot over there. And now I've decided, okay, I've done some good work here. I'm pretty happy to share this with somebody, and we don't have some fancy paper tools, so I'm going to use this amazing Git that everybody is using, and let's go here. So I'm going to say Git Status, and you'll notice that my notebook has changed. Now, you would ordinarily say Git diff, and it would show you the changes in your file, and they would be...
Maybe show that on the notebook, can you?
Unfortunately, I've installed NVDime in this terminal.
Oh, okay. So
yeah, that is rather frustrating. So, actually, do I have it here? Let me... don't worry, it's not on the side. I think this is going to be useful. So I'm going to go here and say clone.
So I think the goal here is to show them the difference between like what happens when you don't have it and what happens when you do have it.
Yeah. Okay, so there I am in the workflow there. I'm going to go to minimal Git. Okay, and over here I will
move that up again a little bit.
Thanks. Cool. All right, so in this one now, and if I quickly make a modification here, now this is different, right? So I'm going to have to do this by hand. Quickly. No, it's not going to work. I'm going to have to open a notebook. Yeah, you see, it's not that simple.
But I guess it's the same, actually. But the kind of view you guys, I think, seeing here, isn't that generally the view that...
You see, so here you can see, because it's isolated to just that line, it looks simple. But actually, the notebook changes because it's got timestamps in the cells and a whole bunch of really complicated stuff. So you can see here, there's the JSON, source, square bracket, so on. You know, here's each of the elements. So it can get a little bit nasty if I was to run the notebook, but I don't have a Jupyter open on that system. If I go over here and I say git diff, you'll notice that it's using NVDime, and NVDime is stripping, cool, thanks, there's 10 minutes left. NVDime is stripping some of the details out, and you can see there the changes that I've made. So that's the role that NVDime plays on in this whole equation, really. The role that Jupytext plays is pretty cool, because what you have is you do want notebooks in your repos, particularly if you're sharing results with people. So if I go to this notebook here, for example, and I click on it, you'll see it renders quite nicely. It's the same in GitHub, obviously, and you can see the results and so on. So you do want some of these results in your repo. So you do kind of want to commit to Ipython, but it's a nightmare for you to track changes because of that JSON body that you have. So what we typically do is we use Jupytext to convert it. So you'll see here I say Jupytext to MD minimal notebook, and I'm going to run that, and it's going to generate a markdown file. And if I now say git status, you'll see that that markdown file there is also changed. I can do a git diff on the markdown file, and you can see here the same code has changed as you saw in the notebook. But now I would like to commit both of these, because if I commit both of these, I can actually track changes in the MD file, but I can render the Ipython file. So it's a nice way of kind of navigating in your repos, and you have both in place. If you're working with production code, that's great, because you can review the MD file with a lot more reliability compared to the Ipython file. Okay, so that is fantastic. You can also go and read about that on the repo. It's all put out there in minimal Git. Over here, we even give you the examples. We show you some Jupyter extensions that you could use. Some of our colleagues use this, and it maintains those 2 notebooks for you. And there's the example as well that I actually just gave. So that's pretty fantastic. Something that is missing in this repo, which I will quickly commit for fun, is a pre-commit hook. Let's go here. LSA. There's the pre-commit YAML. So I'm just going to quickly add that for you guys and push that in. Which branch am I on? Okay, so I'm going to git add pre-commit. Yeah, I've already done that. I'm going to commit add pre-commit YAML. So this thing's handy because you don't have to run that line all the time, right? You can see that I had to run Jupytex. Now, how am I going to remember to maintain those pairs while I'm working? But this thing will run each time you pre-commit install. The instructions are also, I think, in the README. So this is now installed, and now if I actually want to add stuff to my Git, to the repo, it's going to actually build the MD file for me automatically. It's super nice. I will show you what the pre-commit hook looks like. So the minute you type git commit, it's going to actually run this pre-commit hook and execute stuff. So here you can see it's executing Jupytext. It's converting IPyBs to MDs, and if you've got a unit test folder, it'll also run your tests for you, which is pretty nice. Cool. Okay.
That's pretty cool.
And that's all before it pushes to
Git. Yeah.
Git.
Yeah, exactly. So we have a few minutes. I'm going to rush a little bit now. So let me quickly show you. I'm going to sort of git revert this guy. Nope, I can't do that. Git checkout.
I actually do an example, but I think it might just kill the screen share. So I'm just going to keep going.
I'll go quick, yeah. So check this out. So the maybe this time there. So you can see here I've got the IPyB file. I've removed the MD file. Okay, now maybe this is getting a little bit convoluted, but you can check it out on the repo. So I'm going to git add that minimal Git guy, minimal notebook IPyB. Okay, and I will say commit it. Minor changes for demo. Okay, and there you go. And it runs the pre-commit hook and it tells me failed. Please add the paired notebook. Okay, I can do that. I'll run that, and now I'll commit again. And now it's happy. So that's what the pre-commit hook does. Yeah, it's super nice. So, you don't have to struggle with trying to remember. The MD file will always be there, and your IPyB file will always be there with your plots. So it's quite nice. Cool. Okay, excellent. So last but not least, with the very few minutes that we have left, I've shown you the answer already. So I'm going to go to this notebook example guy. And here you can see, this is kind of what a EDA notebook will typically look like. This one's actually quite nice. I'm going to restart the kernel just to keep things honest. I can't remember if it's running or not. Cool. So here we go. I'm going to quickly run this. And this is the kind of state that you would ordinarily get your notebook in. So I'll run that first cell, and now there's a wget command here, pulling from a public GCS source and pulling from a public GCS source. So I'm going to run that cell, and I'm going to run that cell. Okay. And you can see this is a bigger source. It's 18 seconds. It doesn't seem like a lot, but very often these things can get a little bit untenable. You don't want to wait that long necessarily. So your natural instinct is going to be, I'm just going to persist this to my local disk immediately. That's a good instinct. You should do that, right? So I'm going to do that now immediately. And you can see I've already now defined my first stage, right? It was get data, and now I've persisted that data. So I might decide, what, maybe actually it's a little bit early in the process for me. I actually know already what I need to do. So I actually already dumped these to disk, so they're technically already persisted. So my first stage has already happened. Let me read these into memory. Sorry, I forgot. You can actually put the path there for GCS and pull it directly into a frame. But this is typically how it is. You get the notebook from someone else. You don't know what's going on. So I've got these two frames. They've got this common key. I'm going to have to join them. So now I'm in the transformation part. I got my data, and now I'm doing a transformation. Typically, when you get this from someone else or when you're collaborating, there's a lot of this kind of like, I wonder what the data looks like. How does the target distribution look like? It's a skewed target distribution in favor of the 0 class. So this model just has to kind of predict 91%, and we think we're doing well. It's one of those class and balance problems. and there's the other class. So this kind of thing would typically be dangling in the notebook that I got back from someone. You know, I could decide to cull this as part of the work. I might decide that I would want to keep this kind of thing in a notebook. So actually something that we sometimes do is, if you have a brain that's running and you have these stages that are executing, you can still have an exploratory notebook that's a bit messy, that everybody just accepts will be messy. Something that we've actually also found is quite handy is to create a little area right at the bottom of the notebook. And I'm going to use Markdown here and say, there be dragons. And you put all your weird stuff in the bottom. That really does actually help. But I'm going to go up to the top again quickly. And this cell should execute. That's fine. And over here, I'm going to do my join, and I'm going to do, you know, typically a data scientist will quickly inspect the head of that file. Okay, yeah, that looks pretty good. You know what? Maybe I want that committed because I want people to be able to see what's happened there. This guy is definitely unnecessary. I'll delete that. And now I'm going to do a filter on the features that are pertinent to this particular problem. Of course, if you're doing EDA, it's going to take a lot longer. I'm cheating. And, you know, you're going to be having to cull a whole bunch of cells before that. But let me run that one. And now I've done my filter, and now I do my DF head 3, and I see I've got some features back. I see some nans are popping out. Cool. Maybe I'll deal with that later. I'll see what I do. But at this point, I've now done a transformation. And at this point, I'll probably decide, you know what, I don't want to do all of this again. So this to me is effectively a notebook. So I'm going to duplicate this thing, and I'm going to call this one ingest transform. I'm going to combine the first two stages for argument's sake. And over here, I'm going to say this guy needs to be persisted. So I'll say to CSV. Or is it PD.to CSV? I don't have autocomplete on. That's frustrating. Look at that. Where's that magic symbol? Where is it? Okay, I'll be super fast.
It's okay. While you're looking for that magic symbol,
Too quick. No, go.
There you go for 4 minutes. I think before we start closing off, and I mean, you can.
Yeah, you guys can ask questions. I'll keep hacking.
Yeah, you can. If there's any other questions you guys have, please do ask them. I guess it's something I forgot to mention in the beginning, but we are actually actively hiring. We're looking for machine learning engineers, data scientists, data engineers, and software engineers. If anyone is interested, please do get into contact with us.
Okay, so here, you know, if I'm going to follow my own advice, I'm going to put in some clever little timestamp here, right? So that I can quickly, so I'm going to do that, let's say for fun, I'm going to import datetime. Now we're getting into the, you know, the nuts and bolts of Python here, right? It's not that important, but I'll go datetime, now. Cool, thank you. And, you know, maybe I'll do a strf, and I will say I want it in year, month, day. And I'm going to get this wrong, but I'm going to do that anyway. strf time. Cool, there it is, 2020, 1108. Maybe I want it on a minute scale. Maybe I even got days and minutes wrong. Maybe it's not really month there. Sorry, maybe I got the minutes, but it looks fine. I'm just going to take that and say, great, you're going to go in there. I'm done with you now, evil cell. I do need that though. So let's drop it in there, and gone it goes, and persist. And I didn't close. I should have there. Okay, cool. And that's the same as it was before. Invalid syntax. Why are you doing this to me? I've attempted too many times. Okay, up. Okay, let's not be smart. Anyway, this is the kind of convention you should.
It's the single quotes on the inside.
What did I do here?
So just make it double quotes on the outside, or change the inside quotes.
The literals.
Yeah, literals.
Thank you. Cool. All right.
Wait, that's double. There we go.
Boom. Okay, I persisted my data. So now I'm going to go into this sort of command mode, if you wish. I'm going to select all these cells, and I'm going to say out with you. DD. Gone. Okay, and now that stage is complete. I've saved it. The data is being persisted. There it is. And I'm going to shut down this kernel. And I'm going to open this one now. And now we're in stage 2. And I'm going to get rid of all these cells. And where I left off, I'm going to import, and I'm going to carry on. So that's pretty much the idea. So you can work in this way. It's super simple. And it makes things a little bit easier for you to manage. And you're going to commit every single notebook as you go along. So where was I? Somewhere here. PD, cool. And I will say df equals PD, and this will be the last thing I do. Read CSV, this thing, and I'll dump it in there. Whoa!
Oh, it didn't copy.
Let me rename, copy there, there, and there. And now this thing is attached to this version, really, of the data, right? Very, very shoestring stuff, this. Maybe I should run my imports first and run that, and off we go. We're back in business. And now I continue with this stage.
Okay.
Cool.
Nice.
The end.
So I guess there's obviously maybe in summary again, it's about following the specific principles. It's about breaking out into different components. It's about making sure you're visioning all your data, your code, all of that, and then you should be able to have a reproducible.
Yes. And now I've been doing this along my brain's toasted, so I can't figure out how to shut my screen share down.
That's totally fine. So Spatial Edge and Jacques, thank you so much. This was such a joy. So first of all, I learned so much, and I'm using notebooks since like 100 years.
Excellent.
And also for living sometimes. So I will recommend to all my students to watch the video afterwards. It will be uploaded at the IndabaX YouTube channel. So just check that out. I think it happens actually automatically once I close this. Otherwise, I hope I can do it on Monday. Yes, and to everyone else, thanks for watching. I hope you learned something. I hope you also had a lot of joy, like watching basically or looking into Spatial Edge. It was almost like we were in your office and you were just like, oh, chatting a bit, and then someone was like showing us how to do things. So it almost felt like we were starting our job tomorrow, and this was our intro session. So, yeah, thanks for the very charming tutorial.
Cool.
Yes, stay connected. Like interact on Discord if you've got any questions, and have a wonderful weekend, everyone. Thanks.
Cool. Thanks so much.
I do think that YouTube video you're gonna probably have to go on slow or 0.5 instead of 1.5.
Yes, we can slow it down.
Yeah,
Bye bye.
Great. Thanks so much, everyone.
Cheers.